Okay guys, in this section of 4-7 we are talking about solving exponential equations, and so we're going to use some of the properties and things that we've looked at in the previous sections to help us solve exponential equations. Alright, now as it says here, there's really two basic strategies for solving exponential, or when we get to the next section it'll be logarithmic equations. Alright, and so it's using the one-to-one properties, and the other one is using the inverse properties. Okay, and so remember your restrictions from when we first defined the exponential and logarithmic functions. And so, or excuse me, not exponential, just the logarithmic functions here. And remember, the one-to-one properties suggest that if your base is the same and these two are equal, then the exponent has got to be equal, right? And same thing with log. If the base is the same, then here the exponent has got to be equal. All right, so this is just the one-to-one property in exponential form. This is the property in logarithmic form. And remember the inverse properties. Remember what we said, exponential functions and inverse functions are, or excuse me, exponential and logarithmic functions are inverses of each other. And so one undoes the other. And so if you've got an x raised up to a power, you can take the log, right, of that base to both sides of your equation, and that'll make the x fall out. Okay, if you've got a logarithmic equation, right, then you can just raise that exponential to the same base, and that would let the x fall out. So remember these two properties, and these are kind of the strategies that you can use to help you to solve these logarithmic equations. Here they've got it written out. So step one, rewrite the original equation in a form that allows the use of the one-to-one properties. And so what that means is you want to rewrite it into a form where the bases match. If the bases match, then the exponents are equal, and you'll see that when we start doing some of these problems. Same thing for the next one. It says rewrite the exponential equation in logarithmic form and apply the inverse property of logarithmic functions, or rewrite a logarithmic equation in exponential form and apply the inverse properties. All right, and so that's what we were saying, like when you have a exponential, then you can do log of both sides to get that x to fall out of the exponent. And like I say, we'll show you some examples of what that means here in just a minute. And so here are a couple examples to look at to kind of get you started with it. So if I wanted to solve this, 2 to the x power equals to 32. Okay, the strategy that I can use here is to try to make the bases match. All right, so you want to try to match the base on this other side. So 32 can be written as 2 to the 5th power, and now the bases match. Well, if the bases match, then the exponents have got to be the same, and then so that means x equals to 5. And that's from the one-to-one property. Remember, if the bases are the same, the exponents have to be equal. Okay? So one strategy is to try to get the bases to match. All right, so again, we're still trying to get the bases matched, but this one may take a little more thinking here of how that can be done. So I have 1 over 3 to the x power is equal to 9. Okay, so now we typically think about matching bases as having a integer raised up to a power and not necessarily a fraction, because fractional powers are difficult to do in our head. So what we can do is we can actually write this as an integer base. Well, Coach, how are we going to do this? Well, here's the first step. I can rewrite 1/3 raised to the x power as 1 to the x power over 3 to the x power. And then I can write 9, or excuse me, from here, I know that 1 to the x power is just 1, right? 1 to the x power is just 1. Because remember, whatever I put here, you're going to get 1. If I put 10, 1 to the 10th power, 1 times itself 10 times, still 1. Even if I put 0, anything to the 0 power is also 1. So that simplifies to 1. And then 3 to the x can be here on the bottom. Now, remember, I can take this 3 to the x power and raise it up to the top of the fraction, but remember when I do that, what happens to the exponent? Remember your algebra rules? It'll change from positive to negative. So 1 over 3 to the x is the same thing as 3 raised to the negative x power. And then, of course, 9 can be written as 3 squared, and guess what? Now my bases match. Okay, see that? So if you've got fractions, you may have to do a little bit of work to get the bases to match, but it still can be done. All right? Now, you can't always get the bases to match, and in that case, you'll have to use another strategy. But in many cases, you can, with a little bit of rearranging, get the bases to match. Now, if 3 to the negative x equals 3 squared, then negative x equals 2. Well, if negative x equals 2, then positive x equals negative 2. There's your answer. Still the one-to-one property because we made the bases match. What about e to the x equals to 7? E to the x equals to 7. All right? Well, if I want to figure out what the x is equal to, and I've got e to the x is equal to 7, okay, then remember our strategy? Okay, we want to get x out of the exponent, and so what we can do is we can just take the natural log of both sides. Take the natural log of both sides. Because remember, in one of our previous properties, okay, we had, let's see if I can find it for you. In one of our previous properties, so once you take the natural log of both sides and get to this step here, natural log of e to the x, well, let's see what that's going to be. So remember from section 4.5, we said that natural log of e to the x is equal to x. That was one of our properties, inverse properties, because remember exponents, exponential functions and logarithmic functions are inverses. And so once I take the natural log of both sides, natural log of e to the x is just equal to x. And that's what I want. I want to figure out what x equals. Well, what is it equal to? It's equal to the natural log of 7. And then so your answer choices could be in this form. It could say natural log of 7, or it could be a decimal answer. If it's in natural log form, then you would just pick natural log of 7. If they're in decimal form, then you would just put natural log of 7 into your calculator and see what decimal matches that. Okay? By the way, also, if you just take this thing and rewrite it from exponential to logarithmic form by switching it around, remember this becomes natural log, okay, base e of 7 equals the exponent, which is x. And then you've got the solution right there just by rearranging it from exponential form to logarithmic form. We have the solution right there in just one step. All right? So a couple of ways to look at that. Let's see what else we got here. Okay, so now we actually get to some problems that we can solve. All right, so the first one, okay, we're trying to solve 8 to the 3x power equals to 360. Remember, our first strategy should be, okay, let's try to get the bases to match. Well, it turns out, though, that you can't get the bases to match integerally, because if I go 8 times 8 times 8, all right, I'm already past 360 right there. Okay, so I can't write this as 8 to some power, right? Okay, so we have to use another method. Can't get the bases to match. Well, what can we do? Well, remember what we said? If the x is in the exponent, what can we do to get the x out of the exponent? We can do log to both sides. So here's what I need to do, my first step. I'm going to go log base 8 of 8 to the 3x power equals log base 8 of 360. All right, I just took log base 8 of both sides. Now remember, okay, log base 8, you can think of that as a function, kind of like square root is a function. So this is similar to taking the square root of both sides. Remember, log base 8 itself is not a number, but log base 8 of 360 is a number. Much like square root of 360 is, or excuse me, square root is not a number, but square root of 360 is a number, okay? So remember, log, when you take the log of both sides of an equation, you're doing a function to both sides, right? It's like taking the square root of both sides. Square root by itself is not a number, but square root of 360 is a number. So log base 8 by itself is not a number, but log base 8 of 360 is a number. So just keep in mind what this function is and what it represents, okay? All right, so now on this side, what happens? Log base 8 of 8 to the 3x power, remember, exponent and logs are opposite functions. And so what that means is 3x is going to fall out right there. So just in case you're not convinced of that, I'm going to show you this property right here from 4-5. Don't forget your properties. Log of base a of a to the x equals to the exponent. Okay? So log base 8 of 8 to the 3x is equal to 3x. So remember, exponential functions and logarithmic functions are inverses. All right? They undo each other. All right? Let me see here. So on this side, what are we going to get? We're going to use our calculator. Now remember, your regular calculator on your phone probably doesn't have it, but Desmos will allow you to do log base 8. If you didn't have Desmos installed on your phone, then you would, or another calculator handy that allows you to do that, you would probably have to use that change of base formula that we used in a previous lesson. All right? But we don't here. We have Desmos installed. So I'm going to go function, and I'm going to go log base A, because I want log base 8 of 360. And I see that's going to be 2.31. We'll go out 3 decimal places. Since we're dealing with exponents, probably want to be a little more accurate than normal. So we'll go to 3 places instead of just 2. 0.831, we'll call that. Okay? All right, so from here, we're getting close. All I have to do is divide by 3, divide by 3, and then now my x is equal to 0.944. So that's the value of x that would make this equation true. All right, if you don't believe it, you can double check any of these once you get a solution, and that's a way to see if you're right. If you're not sure that you're correct on these, well, take this and plug it in for x just like you would check any other equation. So we'll go 8 raised up to the, and I need parentheses here, 3 times 0.944. You might say, oh, coach, it's 361. Well, that's because we rounded off. So if I go, let's say 1, no, that's not good enough. What if I go 0? Oh, you know why? Because 4 is over, so I'm going to change it to 3, 5, 3, 6, 3, 5, 3, 5, 5 is over, 3, 5, 4. All right, see how we're getting close now? 3, 5, 3, 5, 3, 5, 3, 7, 3, 5, 3, 9, 1, 9, 2, 9, 3. All right, see how we're getting really close to it now? So the reason why is because that it was off a little bit is because we rounded off our answer. But if we put the exact number in there, then it would be correct right on to 360. All right? So that's a way that you can double check those. So anytime if you're not sure, just plug in what you get, double check your answer. All right, what about this one? 500e to the negative x equals to 300. I want to solve for x. Well, just like we would normally do in any equation, we're going to divide by 500 first. 500, we're trying to isolate this e. So it'll be e to the negative x is equal to 3 over 5 is what that reduces to. All right, so once again, I don't really have any way to make the bases match. There's no way I'm going to turn this into base e, right? And so what we're going to have to do is we're going to have to take the natural log of both sides. So I'm going to go natural log e to the negative x equals natural log of 3/5. Okay? Remember what happens when natural log and e get together with an exponent? The exponent falls out, so now I have negative x equals to negative 0.511, which means that positive x would be equal to positive 0.511. There's your answer. Feel free to plug in and double check that you have done it right. You will see that you get the right answer. All right. What else we got? We got a couple more. Let's see if we can solve this one now. Okay, so here, first thing that I would do is move the 7 to the other side, and then I will get negative 2e to the x is equal to negative 2 on this side when I subtract the 7. I can divide both sides by negative 2, and then get e to the x is equal to 1. Once I get e to the x is equal to 1, once again, can't match the bases, but I can take the natural log of both sides, So I'm going to go natural log of e to the x is equal to the natural log of 1. This will fall out and leave me with x is equal to. And so we just need to figure out what the natural log of 1 is. You can put it into your calculator, or if you remember your properties, natural log of 1 equals 0. Why? Because e to the 0 equals to 1. All right? So there you go. You can double check that one if you want to plug in a 0 there. This one checks really quickly. E to the 0 power is 1 times 2 is 2. From 7 is 5, and it checks out. We got it. Okay. Next one. Let's look at this one. All right. Now with this one is a little bit more tricky than the others, and here's why. Okay. So on this one, I've got e, but I've got multiple e terms, and they're different exponents. So they're not like terms. I can't put them together. And so anytime that you've got more than one e term, it's a little bit tricky, especially if you can't find any way to combine them together. All right, and so there's no way to make the exponents or the match here. Let me see. No, okay, so we can't do it. So here's the strategy. What we're actually going to do is I'm going to rewrite this first term in a factorable format. And here's what I mean. I'm going to change this to e to the x squared, and then we got minus 4e to the x minus 5 equals 0. Okay? All right, so e to the 2x power is the same as e to the x times itself twice. E to the x times e to the x is e to the 2x power, right? So remember, when you're multiplying, you add the exponents. Power to a power means you multiply, right? So 2 times x is 2x. So we got to remember our algebra skills. Now, back to the question, why did I write it like this? Because now e to the x can be considered as one variable. And I've got this also, this term is also in e to the x, right? So I've got e to the x squared minus 4e to the x minus 5 equals 0. Think about this e to the x. Let's say I just replaced it with an x. What would the equation read? X squared minus 4x minus 5 equals 0. All right? So that sounds more familiar. We know how to solve that equation. If this was just x squared minus 4x minus 5 equals 0, we could solve that all day long, right? So this is no different, and if we solve that for x, then we would figure out what e to the x equals. All right, so this is a strategy that's used a lot in calculus called U substitution. You can substitute it into something that's more easy to solve, and then when you're done, substitute it back. Okay, but I don't think we need to go that far. We can just factor it just like this. So I'm going to go e to the x here and here, right? Because e to the x times e to the x is e to the x squared. Now in this one, I need this to multiply together to give me negative 5. So I know it's got to be a plus and a minus. All right, so we're going to factor this now. We're factoring it. So I know that this can be 1 and negative 5, so that I can get negative 4 in the middle. E to the x times e to the x squared. Negative 1 times 5, negative 5. What's 1e to the x minus 5e to the x? Negative 4e to the x. And so we've actually factored this successfully now. All right? So from here, now what can we do? Well, we can separate these into two equations. E to the x plus 1 equals to 0, or e to the x minus 5 equals to 0. Okay? And so here we get e to the x equals to negative 1, right? And here we get e to the x equals to 5. All right, so what do I need to do now? I need to take the natural log of both sides to get the x out of the exponent. Okay, so if I take the natural log of both sides here, I would be left with x equals to the natural log of negative 1. Right? And here I would have x is equal to the natural log of 5. All right, so are both of these answers? Let's double check. Okay, another thing that you need to be able to remember from when we first started looking at this, what if I go natural log of negative 1? What happens? It's undefined. Remember what we said when we first started looking at the logarithmic functions? There was a restriction on the number that you can take the log of. It's got to be positive. Remember that? This is the reason. It's undefined. You can't take log of a negative number. And so this one doesn't have a solution here. However, the other one does, and that's going to be my answer. It's going to be the natural log of 5, which is equal to 1.609. All right, so there you go. 1.609. That's the answer. We have one more that we need to do. And so on this next one, we've got 400 over 1 plus e to the negative x power equals to 350. Okay, so on this one, what I'm going to do is I'm going to just take the reciprocal of both sides. Can we do that, Coach? Yes, we can. What if I have this? 4 equals 8 over 2. That's true. What if I take the reciprocal of both sides? Does 1 over 4 equal to 2 over 8? Yes, it does. So remember, you can do anything to an equation as long as you do the same thing to both sides. You're good. So I'm going to flip this and go 1 plus e to the negative x over 400 equals to 1 over 350. Got to take the reciprocal of both sides. 1 over 350. Now let's multiply both sides by 400 times 400. We'll get that to cancel. Now on this side we got 1 plus e to the negative x equals to, let's see, if you were to multiply that out, you would get 8 over 7, because 50 goes into 400 8 times, 50 goes into 350 7 times. All right, what do we want to do now? How about subtracting 1 from both sides? E to the negative x equals to 8 over 7 minus 1. So now e to the negative x would be equal to 1/7 when I subtract those two, right? Okay, so we're getting closer now. What do we want to do now? Take the natural log of both sides to get this negative x out of the exponent. So negative natural log of this side makes the exponent fall out. And then natural log of this side, which is natural log of 1 over 7. So if negative x equals to natural log of 1 over 7, then x equals to the negative natural log of 1 over 7. And you can't take the natural log of a negative number, but you can make the natural log itself negative, right? We can do that. And so now it's just up to my calculator to see what the answer is, and let's go see what it is. So I need to go back in here to my Desmos calculator, and we'll want, what do we want? We want negative natural log of, let's make a fraction there, 1 over 1 over 7. All right, so there you go. It's 1.946 is your answer. Okay? All right, so those are the strategies that you can use to go through and solve these exponential equations.